Good morning.
Morning.
Hi, Jen.
Well, I hope you're all doing well. Did anybody do anything amazing over the weekend?
I went to the valley for my grandma's birthday.
Oh yeah? So what
Yep.
did you do there?
Well, I went out to eat 3 times a day, and that was nice.
Nice. I thought you were looking a little bit stuffed.
Thank you.
All right.
I went
Let's
to my
see.
sister-in-law's baby shower.
And what did you? What was the coolest present there?
There was a Spider Woman shirt and a Batgirl jacket and pants.
Good answer. Good answer. Anybody else?
Yeah. Well, we had the Painted Desert Marching Band Festival.
Oh, how did you guys do?
As a band, we got rated excellent.
Nice.
We got outstanding music, outstanding percussion, and outstanding auxiliary.
And what group are you in?
I'm in auxiliary. I'm in color guard.
Awesome. All right. Well, outstanding.
Thank you.
That's very very cool. Okay. Let's see. Somebody help me out here. I don't know. I think because we were going to.
Can I say something about the midterm?
Yeah. Oh.
Okay.
Yeah. Give me
Okay.
1 second.
All right.
What practice problem were we on? On 3.5? Because I think what happened, I think we were on practice 3.
Yeah, we are.
Yeah, I think
Is that
that's
right?
right.
Okay. All right. Okay. All right. Now, okay. So, couple of things let's start about the midterm. So, Lauren, go ahead.
So our class kind of discussed some of the problems after the fact.
Okay.
And there was a problem from 3.4, and you had told us that it was going to 3.3.
Okay.
So there was one of those variation problems, and I know some people struggled with it because they weren't told they had to study those for the midterm.
Okay. All right. Let me make note of that. Thank you.
And then there was one problem that quite a few people in our class missed because there was a division bar and it wasn't clear what was over the division bar. It was just written weird.
All right. I'll take a look at that.
Okay, thank you.
Yeah, somebody said they saw the fraction bar and they were like, "Well, does that mean divide or is that a fraction?" Well, it means the same thing.
Well, it was x minus, and then it was a parentheses over something like
Yeah.
that. So some people
It
thought
was
that the whole entire thing
confusing.
was over.
Yeah.
Okay,
But-
I'll
Because
take a look
if you put it into the calculator, it gives you one of the wrong answers.
at it. Right.
So
Okay,
Yeah.
I'll take a look at it and see if see what's going on there. Sometimes sometimes when the Moodle updates, it changes the format of the problems, and so if it's not lined up right, then I can see. Anyway, I'll take a look at it. But the variation problem, if that is indeed the situation, then I already did the curve. The curve right now would be was 6 2/3 points, so 6.67 points, and so I went ahead and added that in to everyone's grade. But if it turns out that there's another, if there's a question or two, then I might go back and up it some more. Okay. So I'll try to let you know about that tomorrow. Let's see. Anything else about the midterm? Okay, now the other thing is remember, I'm still getting people that were wanting after the midterm and even today asking me to open up quizzes and tests. Okay, and the answer is no. Once you took the midterm, that first part, that's in cement. Okay, I'm not opening up stuff. Okay, you had your chance, you put it off. You shouldn't have done that. Okay, hopefully learn from that. And when it comes the next time, I'm not going to open up anything is after the final exam. And you might think, well, surely. I mean, but literally, I would have emails a week after the class is over, and I've already turned in grades, and people are still wanting me to open up quizzes and tests. Okay, not doing it. So the next, so from where we are now to to the end, I'll open stuff up until the final exam, and then that's the next deadline. Okay. Now the other thing I want to just comment about is just your overall grade. Is that because I do a lot more grades than a lot of other teachers, is that I've had some students say, well, they only have like 3 grades in a class or something like that, or 3 major tests, and I have a lot of grades. So if you do poorly on any one thing, you'll be okay. You can still recover and do okay. But if it's a pattern now, if at this point, if you're not doing well on tests in the midterm, then you need to change up what you're doing. You need to practice more problems. You need to study more for tests. You need to do something a little different. Now, having said that, if I were doing, I also do an overall curve of the grade. And right now, because no one got 100 on the midterm, that it's actually, if I were going to curve, and I have to be careful how I say this, because I don't want I'm not doing this, but if I had to do your grades right now, there would be a 4-point overall curve. Okay? So if right now you have, if you have an 86 in the Moodle and you're really upset, or a 76, or if you had a 76, you would have a B for this class. Okay? So today. Now, I'm not saying that the final overall curve will be 4 points. Sometimes it's 2 points. Sometimes could be more. But so I don't want you to write down, there's going to be a 4-point curve. I'm just saying, as of today, there would be an overall curve. Okay? So I don't want you to count on that. I want you to work as hard as you can, but just know that I try to take into account if there's, crazy questions on the test or whatever, it'll all work out. So, okay. Any other questions or comments about your grade? Also, I put in the extra credit for the football game too. So if you were here that day, you should see 5 or 7 points. And I wasn't sure if you wanted those in quizzes or tests. And I forgot to ask you. So anyway, I went ahead and put it in the test. Okay. So, all right. Any other questions, comments, concerns?
Oh, there was on the second part of the midterm when you went to go take it. It said that you had 2 hours for it, but then it would kick you out after 1 hour. I don't think any of us had an issue with that because it only took 1 hour, but it did say that you had 2 hours to complete.
Yeah. What happened there is you still had a time limit, but you could have actually gone in at any time. And what happened there is there was a little issue as far as I was changing up something. I had to retweak it, and I was in Utah, and I wasn't sure if it was adjusting for the time change or not. So that's why you still had an hour time limit, but I made the window 2 hours because I wasn't sure how it was going to handle that. So I wanted to account for it. Oh, one question. Were both the variation and the division problems, were they both in part 1?
They were in part 2.
They were in part 2. Okay. All right. Okay. Well, let's go ahead and get going. So today the plan is to finish 3.5 and to start in on 3.6. Now, just so you know, so that 3.6 and 3.7 are not terribly long, so we'll see. I mean, it would be nice if we could finish chapter 3 on tomorrow. However, even if we finish chapter 3, I'm not going to give you the chapter 3 test until next week. Okay? All right. Well, so we were on practice 3 here, and it says, so the function g of x shown in the figure is a transformation of the graph of that f of x equals x to the 4th. Find an equation for the function. Okay? So let's just see if you can do that. So see if you can figure out how far it's moved and what you would do. I mean, I know it's been a week since we did this, but let's see what you remember. All right, Lauren, what do you have?
I have f of x equals negative parentheses x plus 3 close parentheses raised to the 4th.
Okay, very good. So the negative is what causes it to go down, and then the parent function is x to the 4th, so that's what it's telling you to compare it to. And then the x plus 3 inside the parentheses is what moves the vertex over 3 units to the left. So
Okay, I was wondering, a few of us were wondering, the negative on the outside of the parentheses, shouldn't that change the positive inside the parentheses to a negative?
no, because you wouldn't distribute that anyway because it's raised to the 4th.
Okay.
So you can't really distribute it. So, but the negative in front of a function, that reflects it through the x-axis. Now, if you had like a negative inside the function, then like a negative, well, it would be parentheses and then negative parentheses x plus 3. Like a negative inside there as well, then that would reflect it through the y-axis. But I wouldn't give you one like that where we'll do another one where you can see that. Okay, so you see this, for example, this is the square root function and it's reflected through the y-axis. So it's going the other way. And so there the negative would be inside the function. So if you think of this as like the regular square root function, and then this is the reflected version, and then this would be shifted up 5. Okay? So this is when you have a negative inside the function, that's what reflects it through the y-axis. A negative out front of the whole thing reflects it through the x-axis. Okay? All right. Okay, so if you're unsure if you have the correct shift and reflection, put it in the calculator. So that's your way of checking to make sure that you've got it right. So like on the last one, if you weren't sure which way it reflected, then just put it in the calculator and check and see if you've got the right drawing. Okay. All right. So this is write an equation for the function whose graph is shown. All right. So now let's see on this one. Yeah, just realize that each tick on this graph is worth 2. And then, so write your equation. Then if you're unsure, just check it in your calculator. All right, so Kinsley, when you've got it.
I have negative parenthesis x plus 6 parenthesis squared plus 4.
What's up with this?
That's it. So the negative g of x equals, so the negative has to go out front. That makes it go down. And then the vertex is shifted 6 units to the left. So you put the plus 6 inside, and then it's shifted up 4. So plus 4 on the outside of the parentheses. So great job. Any questions? Okay. All right. Okay, so now we're going to talk about non-rigid transformations. So non-rigid transformations are those that cause a distortion. So that's a change in the shape of the original graph. So like when we're talking about like a parabola that opens wider or narrower, that's a distortion. So that's a non-rigid transformation. Okay. So some examples are these, what I've got it highlighted here: a vertical stretch, vertical shrink, horizontal stretch, and horizontal shrink. Those are some examples of non-rigid transformations. All right. So let's see what you remember. We actually did these in chapter 2 as well. So it says compare the graph of each function with y equals x squared. Okay, so just do a rough graph. That's the parent graph of the squaring function, the quadratic. So I expect you to know what that looks like. Okay, and then if you have a different color pencil or whatever on the same graph, or make it dotted, or anyway, whatever you want to do. So I want you to graph these on the same graph as y equals x squared, and then we're going to compare them. So Desiree, on the first one, when you have a 4 in front of the x squared, does that make the graph wider or narrower?
Narrower.
Narrower. Okay? So when you put a number in front that's bigger than 1, it makes it narrower. And if you put a number in front that's between 0 and 1, then that makes it wider. Okay? So if this is x squared, then this would be 4x squared. Okay? And if this is x squared, then this would be 1/4 x squared. Okay? Now, if you put them all together, then you get a menorah. No, not exactly, but pretty close. Okay? All right, any questions on that? I guess if you count the y-axis. All right, so the order of the transformations. So kind of putting the whole thing together, you do the horizontal shifts first, then you're stretching and shrinking. So figure out if it's going to be wide or narrow, then the reflections, and then the vertical shifts last. Okay, so in place of practice 6, I want us to do this one together first. So you can just cross out practice 6 on your paper, and let's do this one together. Okay, so here's the equation. So what is the parent graph? All right, so Serena, what's the parent graph? What's the graph we're going to compare this to? There's really nothing to calculate here. You just look at it and either recognize the parent graph or not. You can't phone a friend. You got to know it, okay? All right, can anybody help us?
It's y equals the absolute value of x.
Yes,
right?
So the absolute value function is the parent graph, okay? So you need to, show me in the air, what does the absolute value function look like? Okay, yes, the v. So you've got to know that. Okay, I'm expecting you to know that, and the vertex is at the origin. So when you move it, that's the point you're going to move. Okay? All right, what is the horizontal shift? Jocelyn, what's the horizontal shift here?
Two to the right.
2 to the right. Very good. Because the -2 inside the function moves it to the right 2. Okay? Good job. All right, next. Wider, narrower, or the same opening as the parent graph?
Turn it off.
All right, Jocelyn. That one's yours too.
Narrower.
It is narrower because the 4 is bigger than 1. Okay, so that makes it narrower. All right, next. Does the whoops,
Question,
whoops. No, okay.
Mr. Strong.
Yes.
So, when you're talking about narrower or wider, when you say it's less than 1, so -4 is less than 1?
Okay, the negative does something else. So we're just talking about the 4.
All right then.
The 4 part. The negative actually, well, let's go to the next question. Does the graph open up or down? And let's have Tara. Does the graph open up or down?
Tara's
Not
not
here.
here.
She got
Oh.
6, but she went home.
Oh, okay. Who is there anybody else missing in Holbrook? I forgot to ask.
Tara
Ina?
and Ina.
And Ina. Okay. Thank you.
Wait, is Hannah?
Yeah.
Okay. Well, can somebody just tell me, does it open up or down?
Down.
It opens down. So you look at the negative makes it go up or down. I mean, the negative makes it go down, and then the 4 is what makes it affects the aperture, the opening. Okay. All right. All right, and then what's the vertical shift? Ricky.
That's just 3, you know.
Which way?
Oh,
Up. Okay. So, because down 3 could well, anyway. Yeah, it's up 3. So up or down is considered a vertical shift. Okay. And then, so now do a rough graph of it on your paper there. All right. So your graph should look something like, okay, so like the red one. So I kind of, moved it over and the parent graph, but then when you shift it, so it's over 2, up 3, and then it goes down and make it a little narrower. Okay. So that's just kind of putting it all together. All right. Any questions on the graph? All right. Okay. All right. Well, that's it for 3.5. Any questions before we go on to 3.6? Okay. So, all right. So 3.6 is on combining functions. All right. So what are we going to do in this section? This section to me is pretty straight up because when we talk about combining functions arithmetically, it just means we're adding, subtracting, multiplying, and dividing. Okay. So I guess, well, anyway, composing and decomposing functions, and that's pretty much it. We don't really do much on recursive graphics. It's kind of cool. I might show you. But anyway, okay. So adding, subtracting, multiplying, and dividing functions. The first real trick is to understand the different ways that you can write them. Okay. So you could write adding functions as f plus g of x or f of x plus g of x. And subtracting functions f minus g of x is the same as f of x minus g of x. And then multiplication, f times g of x is the same thing as f of x times g of x. And then f divided by g of x is the same thing as f of x divided by g of x.
Mr. Strong, I have a question.
Yes.
Why wouldn't the last one f divided by g, why wouldn't that be f times x divided by g? Because if you
now remember, in function notation, it's never f times x.
oh
It means the f of x.
oh yeah, okay.
Okay. The f, that's just the name of the function, and you're plugging x into it. Now, the ones that you're writing down on your paper, the ones over here, are the ones that how I prefer to write it. But for some reason, most mathematicians or in most books, they like to write it on the left. I like it how it's written on the right better. Maybe it's because that's how I learned it, or it's a little more clear what you're supposed to do. I don't know. All right. So first, that's just addition. So, okay. All right. So if we're adding two functions, basically you just combine like terms. Okay. So you're adding these two together, and then you look and you say, okay, there's no like terms with the x squared, so you just bring that down. 2x plus 2x is 4x, and then 1 minus 1 is 0, so the 1's cancel. So that's it. Okay? Now, if let's say if you had the f plus g of a number, well, so you could add them up and then plug in the number. That's probably the easiest way to do it. So then you plug in 2, say here, and then you work it out. And so you'll get a number for your final answer. Okay? All right, so go ahead and do practice 1A. All right, so Hannah, when you've got it.
Hannah had to step out real quick.
Okay. All right, so do you volunteer as tribute? Go ahead. Anybody in Holbrook, tell me the answer.
Is it negative? No, is it 21?
Is it 21? The answer is 21. Good job. Any questions on that? Anyone like me to work it through? Is that a question, or you want me to work it through?
Can you please work through it?
Sure. Okay, so we're adding the two functions together. So we have x squared plus 1 minus x. Well, there's no like terms. So here I just rewrote them in descending order. And so you get x squared minus x plus 1. Then to do the f plus g of 5, now in place of x, you plug in 5. So 5 squared is 25, minus 5 is 20, plus 1 is 21. So were you having problems with the combining or plugging in? Okay. Let's just go on then. All right. Go ahead. Okay, so to evaluate, we can substitute first or simplify first. So, for example, why is that covered up? I don't know. So let's say here's my two functions, and I want to find the f minus g of x. All right, now, in this one, it actually says to subtract and find the function, then evaluate. But if all we needed was the answer, we could actually plug in the two from the very beginning and then subtract them. But this, it actually says find f minus g of x. So I really need to do that first. Okay, so here I'm going to take 2x plus 1, so f of x, minus x squared plus 2x minus 1. Now, when you're adding, you can just drop the parentheses with no problem. But when you're subtracting, when you drop the parentheses, you need to distribute the negative. So that's the most common mistake that students make on this. So you drop the first set of parentheses, then when you distribute the negative, you'll get negative x squared minus 2x minus a negative 1 becomes plus 1. Now you go through and combine the like terms. So there's no like terms with the negative x squared. 2x minus 2x cancel. 1 plus 1 is 2. And so you get that. All right, now, so that's the answer to the first part, the f minus g of x. Now you plug in 2, and so you plug in 2 for x, so you get the negative of 2 squared plus 2. So that's negative 4 plus 2, which is negative 2. Okay. Now, note this right here, because this is probably the second most common mistake on this problem, is when you plug in 2 here, see, negative x squared is not the same as the negative of x squared, because this one on the left would give you a positive, this one gives you a negative. So if you're plugging in 2 for x, you're going to square the 2, then take the negative. You don't square negative 2. The exponent has higher priority than the subtraction sign. Okay? So just kind of watch out for that kind of thing. All right, so go ahead and do practice 1B. All right, so Taylor, when you've got it.
Is it 5?
Is it 5? Well, let's see. The answer is 5. Great job. Okay, would anyone like me to work through that? All right. Well, beautiful job. Let's go on. Okay, any restrictions on the domains of f or g must be considered when forming a sum, difference, product, or quotient. So what that means is if we have two functions and we don't allow you to put in 5 in this one, and we don't allow you to plug in 0 over here, then when you add those two together, you can't plug in 5 or 0. For example, okay, we've already restricted the domains. Okay. Now this is going to become more important when we do the division. So here, where we're just finding, so we're finding the product and then evaluating at x equals 4. Okay. So here, when we take a product, you're just multiplying one function by another. So x squared times x minus 3. And so then when I distribute that, I get x cubed minus 3x squared. So that's f times g of x. So then to evaluate it at x equals 4, or find the f of times g of 4, now you plug in 4 into the function. And so you get 4 cubed minus 3 times 4 squared. And so then we work that out, and we get 16. All right, any questions on that? All right, so go ahead and try practice 1C. All right, so Jay, when you have the final answer, let us know.
How to do it? 13.
13, he says, and I got 13. Great job. Any questions on that? Would anyone like me to work it through? Okay. All right.
Mr. Strong, sorry, but I do have just one question.
Okay.
So, it says, given f of x equals x squared plus 4 and g of x equals x minus 2, that, and, doesn't that mean it's added?
You know, that is actually a great question. And I want to tell you something, is that, so I remember being in a class and we asked something similar to that. And the teacher said that something like after the 5th grade, like 50% of the math that you learn is that the math that you were taught before is wrong. Okay? Like like when you first learn about subtraction, there's always one kid in the class that says, well, how do you subtract like 2 minus 5? And the teacher says you can't subtract that way. And then later you learn about negative numbers, and then you learn that the teacher lied to you. Okay? All right, so here's an example where some elementary school teachers are sloppy in how they teach the word and. And they say, oh, and means plus. So what's 3 and 5? Okay, they want you to add, right? See, that's sloppy. And does not mean add. And just separates the two operators. So what they should say is, what's the sum of 3 and 5? Or because the product of 3 and 5 means multiply. Or the quotient of 3 and 5 means divide. Or the difference of 3 and 5 means subtract. So the and does not mean add. It separates the two things that you're operating on. Does that make sense?
Yeah, but then what indicates that you're supposed to multiply them?
Because it says evaluate f times g of 3.
That makes more sense. Okay.
So that's a great question. And especially with, like I said, where you were taught something incorrectly. Okay? So thank you for that question. All right? Any other questions on this one? See, I would hate it, Naomi, if, like on a test, you missed a question because you misinterpreted the and. I would hate that. So I'm really glad that you asked. Okay, so next, so division. To find the domain of a quotient, we have the added condition that we have to omit those elements for which the denominator is 0. So you can't ever divide by 0. So you might not have any restrictions on f and g, but when you start dividing them, then you might have to, whatever makes the denominator go to 0, you got to throw that out. Okay, so this says, now you got to read it carefully, these questions. So this says find the g divided by f. So don't always assume it's going to be the top one divided. This one, so this one is divided by this. So what can x not be if if radical x is in the denominator?
It can't be negative.
It can't be negative, and it can't be, what else? If it's in the denominator, specifically.
Negative.
0.
Cannot be 0. So, see, if the radical x is in the numerator, it can't be negative. But all of a sudden, when we put it in the denominator, make it g divided by f, well, then you have to throw out 0 too. Okay? Now, when it says to write these, I mean, I know this is, to me, it's almost silly because they actually don't ever have you divide here. What they do is they just have you write the numerator over the denominator. You don't actually ever write that. I mean, you don't actually divide. And so then the domain would be all numbers that would, for the denominator, you'd have to throw out not only the negatives, but 0 as well. Okay? So on practice 1D, when it says find f divided by g of x, all you're doing is writing one over the other. Okay? And you don't actually do any division. Then plug in, let's see. And then it says find the domains. So look for things that would make the denominator go to 0. Okay?
What quizzes are we taking on Wednesday this week?
I believe we already took 3-1. So according to my records, we're going to do 3-2, 3-3, and 3-4.
Okay.
Does that sound right? Okay. All right, so Rebecca, what is f divided by g of x?
X squared over 1 minus x.
Correct. And what would you have to throw out of the domain? What can x not be in that problem?
1.
1. Okay? Good. Because, see, if you put a 1 in here for x, then you'd get a 0 in the denominator. Okay? So you'd have to say the domain is going to be all real numbers except 1. Or just say x can't be 1. All right? But look, did we ever do any division there? No. You're just writing one over the other. It's kind of stupid. All right? Let's do the last one here. All right. All right, so Kinsley, what's g divided by f?
It's x minus 1 over x squared.
You mean 1 minus x.
Oh, yeah, sorry.
Okay? And what can x not be in that one, Kinsley?
0.
X can't be 0. Because that would give you a 0 in the denominator. So in the first one, x can't be 1. In the second one, x can't be 0. Because that would give you, again, a 0 in the denominator. Okay? All right. Well, that's a good place to stop right there. So, any questions before we call it? All right. Well, you guys have a great day, and we'll see you tomorrow.
Thanks, Mr. Strong.
You bet.